Good morning, everybody. My name's Steve Morris. I'm the Operations Manager for the Gas Turbine Research Centre, which is run for Cardiff University, and it's based in Port Talbot, just next to the Tata Steelworks. So I'm just going to take a little bit of time today to introduce our activities under the West programme. So I'm going to give an overview first. So we're just going to introduce our research theme. Then I'm going to talk about large-scale power generation and low-carbon policy, and really the drivers there for the research, but also drivers for the required training. Then I'm going to talk a little bit about the industrial engagement that we're already involved with, and also what we then believe to be the appropriate training methods or delivery methods for that training. We have actually delivered a piloted course as well, so I'm going to talk a little bit about that and our future developments of the courses. So as I mentioned, it's the Gas Turbine Research Centre. It's based in Port Talbot. We've got lots of projects on, but the main research theme for us under the Low Carbon Research Institute banner is something called LSPG, which is large-scale power generation. Now that started off 2 or 3 years ago. Really, the driver for that was to look at alternative gaseous fuels for natural gas. So we were looking at process gases, biogases, things like gasification of waste and things like that. But really, it's changed quite a lot in the last year with the viability now of coal bed methane and shale gas. Things have changed a little bit. So really the large-scale power generators are really interested now in actually the variability in the gas composition in the gas main. So we're getting our natural gas now from the North Sea, from Norway, from mainland Europe through the Ukraine. We're also getting LNG, and there's talk in the future of hydrogen coming into the main, and also biogas. So there are lots of challenges to sort of try and operate gas turbines when this gas composition is varying. So that is really the challenge. So to enable that, or to enable the research, we've had to build our own gas mixing facility. So we have a large-scale 2 megawatts gas mixing facility, which now enables us to mix up to 5 different gas streams. So, the types of gases that we're talking about here are hydrogen, carbon monoxide, methane, and then inerts such as CO2 and nitrogen. Also, to facilitate the research, we've actually designed our own generic burner. Now, that burner is actually based on a sort of an industrial standard, but the beauty of it is that it's a flexible burner. We can alter its geometry, so we can change swirl number, we can change expansion ratios, acoustic responses. So there's lots of things that we can actually do with that burner. And our plan here is actually to try and find a burner geometry which is fuel flexible. That's the holy grail. It's going to be very difficult when we start talking about sort of high variability of fuels, but that is the goal, at least to understand the effects on combustion. Collaborative projects that we're working with, we do a lot of work with Tata Steel. As you may or may not know, they have large volumes of process gas, something called there's coke oven gas, which is 65% hydrogen, there's Boss gas, which is 60% carbon monoxide, and there's also a blast furnace gas, which is a very low calorific value fuel. So those 3 fuels behave completely differently in a combustion environment. We work with a company in my state called SCA Hygiene. They're a tissue manufacturer, but they actually run 2 gas turbines for steam generation. So we've been doing quite a bit of work with them to looking at extending the life of those gas turbines. And then on a sort of a smaller scale, 2 SMEs. One is Ref Gas, which is actually based in North Wales. And there's another one which actually isn't on there. It's a company called Welsh Energy Management, based in South Wales. Both of those SMEs are involved with energy conversion technology, so things like pyrolysis and gasification. So they take municipal solid waste or biomass, and they convert it to heat and power. So really it's a broad combustion-related theme. We're interested in emissions, combustion stability, burner design. So there's lots of interesting themes there. So what are the drivers? There were some very interesting speeches yesterday, the keynote speeches for myself in the gas turbine sort of arena. It was very interesting to hear some of the keynote speeches. From a power generation point of view, by 2030, we're looking at a reduction, a 2/3 reduction in our CO2 emissions from power generation. Then by 2050, we're looking at 0 CO2 emissions. But interestingly that's based on the forecast that our energy demand is going to double. So how are we going to achieve that? In the short and medium term, we're going to need more natural gas-fired power stations. You heard a lot of talk yesterday about CCGT, which is a combined cycle gas turbine. Now that involves an open cycle gas turbine linked to a steam turbine, and that way you can bump up the efficiency to something like 60% conversion. There's going to be more use in bioenergy. So bioenergy is really the use of biomass, biogases in a sort of a combustion environment, and we'll be looking at also improved efficiencies and CHP. Long term, because we're going to have we're still going to be using a lot of gas. You know, it's unfortunate, but it's fact. We are going to be using a lot of gas, so that we're going to still be producing a lot of CO2 in our power generation. So we're going to need to capture that CO2, and we're going to need to sequester it. So in the long term, we need to introduce CCS technologies. Interestingly, though, the carbon plan here by the HM government, they still believe that 2/3 of the gas-fired power stations will be unabated by 2030. So that's quite interesting. If we then look at industry, by 2050, 70% reduction in CO2, again though with a 30% increase in production. So how are we going to achieve that? In the short term, we need to improve our efficiencies, so material efficiencies and process efficiencies, introducing combined heat and power systems, trying to utilize any of the high grade or low grade heat that may be coming off processes. Medium term then, let's try and replace natural gas and sort of hydrocarbon fuels with renewable and sort of biomass related fuels. That's something that Tata's doing at the moment. They want to be sort of energy sufficient or energy independent on site, I think by about 2015. So it's very that's very close. So at the moment they capture all their coke oven gas, boss gas and blast furnace gas, and they run all their power generation on site off those gases. There was some figures banded around a couple of years ago. They used to flare off the equivalent of £50 million worth of natural gas per year in these process gases. So there's some big savings there. But these big users or big producers of CO2 are going to really have to start considering CCS as well. So our industrial engagement, we've done quite a lot of activity with Tata Steel because of our location. We're right next door to Tata Steel. So we've been running some basic combustion courses for Tata over the last 4 years. And again, it's really important, those courses, just picking up on what John has just been talking about, when we start to, it's management of change. When you start using different gases in this, you need to understand the health and safety implications of that. If you start using a high hydrogen content fuel, what are the risk implications? So we talk a little bit about risk and hazard for these alternative fuels. There's also toxicity issues as well. When you're running something like carbon monoxide, toxicity becomes a really big problem. So we look at health and safety, but we also look at then combustion efficiency. So we try to teach the operators in the steelworks to actually operate their burners and furnaces more efficiently. So we've also tried to engage there with companies. So we've sent out over 70 questionnaires to companies in the convergence zones, and we've contacted all the Welsh power the power stations. We've had 9 responses to the questionnaire, which seems very low, but in that kind of mail shot scenario, over 10% is actually not a bad result. So what's actually required then? What is the need? So there's a broad support there for energy conversion technologies and improving combustion efficiency and emissions. So those are the main needs. There's also some specific gas turbine training that's required at a higher level for the large sort of power stations. They're the ones that are employing the new sort of gas turbine technology. We've also undertaken interviews with Tata Steel and employees from SCA Hygiene just to get their input. So as I mentioned at the start, we've actually piloted a 3-day accredited course in low carbon combustion. That was done in May 2013 with SCA Hygiene. We had 5 participants. The sort of feedback that we got from that was very positive. So the most useful skills learned, how to fault find burner inefficiencies, and then be able to make informed decisions about what to do with that burner, whether it be to change the air to fuel ratio or something like that. Balancing chemical equations is an important tool. Particularly when you're using different fuels, you need to know what the stoichiometric air to fuel ratio is. And when you start to blend fuels as well, that gets quite complicated. And then understanding flame characteristics. So if you can see the flame, and actually you can sort of judge how well that flame, how efficient that flame is just by looking at it. So you give people some tools based on looking at exhaust emissions, what the flame looks like, furnace temperatures, give them the tools and they can actually work out where they are on this sort of efficiency curve, and they can make sort of appropriate adjustments. What we did find though, so maybe one of the negative aspects of the course, it was very intensive. So it was a 3-day course. We actually tried to pack in too much into that 3-day course. There were lots of lecture sessions, but we did actually break out and have demonstration sessions as well. But there was, I think there was more of a need for these sort of breakout practical sessions as well. I think they were maybe in a lecture environment for maybe up to 2 hours at a time, and I think we really need to cut that down to a maximum of an hour, give them a break or give them some activities to do. And remember, a lot of the people who are coming on these courses may not be used to the sort of university environment of sitting down for lectures. So they may be, just not used to that. So we've got 3 main delivery methods. I'm going to say just sort of higher level, or sort of the overarching PG certificate in low carbon combustion, which is going to be delivered in a traditional HE route, which is 60 credits. Then the pilot course, where I've just talked about, a 10-credit CPD award in low carbon combustion at level 4, and then the more easily accessed 1 and 2 credit CPD awards, particularly I think, which is really important, is particularly through e-learning. These particularly sort of individuals working in SMEs, they don't want to spend the time sort of leaving their place of work. I think having access in their own time to e-learning is a very valuable tool, and I think that's probably going to be the most successful way of delivering this type of information. How we fit then as a group within the whole West Business Learning Suite. So you can see there are 5 LCI partners. We've just heard from John then on the hydrogen. We're sitting in that sort of on that petal in that sort of bottom left-hand corner, and I'll talk a little bit more then about the PG certificate. As Julie mentioned, there'll be 2 core 10-credit modules: the enterprise in low carbon economy and low carbon economy and policy. And then we come into sort of our expertise. We do an introduction module into low carbon combustion, and then more in-depth modules then on energy conversion technologies, district heating, gas turbine technology, and an alternative and renewable fuels. So that will total then a 60 credit, PG cert. Then looking at the 10 credit CPD course in low carbon combustion, this is actually the course content from the piloted course. So it was a 3-day course based at the Gas Turbine Research Facility in Port Talbot, which is important. That enables us to be able to provide the practical demonstrations. Day 1, first session, consisted of basic combustion science. So we look at things like stoichiometry, the fire triangle, what you need actually for combustion. And then in the afternoon, we do a demonstration then before lunch. Then we talk about the nature of fuels, where do fuels come from, how can we use them. There are short assessments at the end of each session as well. Day 2 there is then looking at controlling and employing combustion. So again, demonstrations. The participants then look at balancing pre-mixed flames, looking at internal combustion engine principles. Another assessment in the afternoon. We look at energy conversion technologies. We give them an option there. There are 3 options. They can actually either have a 2-hour lecture on gasification pyrolysis, or gas turbine technology, or bespoke sessions depending on their sort of industry needs. That was a very important thing actually as well, is talking to the company and finding out really specifically what training they need, or what information they need. So you build that option in there to have a bespoke session. And then really to combine them all, then we talked about steam cycles and combined heat and power. The last day then we talk about combustion risk and hazards. So we've got some quite nice demonstrations there of explosions and fires. And then finally combustion emissions, which is very important. What causes emissions? How can we actually improve those emissions, and abatement technology? At the end of this 10 credit course, there's an independent learning session, a written assignment to gain accreditation. So there was a 100 to 150 word essay that they had to prepare in their own time and submit for review. Then the 1 credit e-learning CPDs. So these are a standalone accredited small CPD session, approximately 4 hours in nice sort of 20-minute bite-sized sessions, and again they can be completed at the participant's convenience, which is the really important thing. So initially we're developing 2 CPDs, and the nice thing about it, we're actually taking out day 1, the morning session and the afternoon session, and we're using that information then to develop these small CPD courses. So a successful completion would mean then, if you do the 2 courses, you've actually completed the first day of the 10 credit CPD course in low carbon combustion. So that means you'd only have to spend 2 days at the Gas Turbine Research Centre if you wanted to complete the 10 credit course. We're then also going to be working on a specific gas turbine small CPD, and so we propose to offer greater delivery flexibility. What's that? Should somebody want to study both types of energy conversion technology and offer in the 10 credit CPD, not quite sure, it means basic commercial course available. I think what we're talking about there is the middle of day 2. We can give options there on whether we want to talk about energy conversion technologies like gasification and pyrolysis, or gas turbine technology. So our timeline, we can really pull out any of those sessions from that 10 credit course at the moment because it's already been delivered. So really, in January 2014, we could offer 1 credit CPD courses. I think at that point, though, they wouldn't be accredited. So it would just be, I think that the participants could have just a certificate of attendance at that point. But we're working heavily now with Andre to really get this first basic combustion science 1 credit e-learning course up and running by the end of February. And then moving out, then we want to get our second 1 credit e-learning course on the nature of fuels by the end of end of June, beginning of July. And at that point, hopefully we'll have accreditation by Agored for our 10 credit course as well. And then in the future, we've just talked about this gas turbine technology course and developing this gasification and pyrolysis, this energy conversion technology. So that's a very quick overview of what we're doing. Please contact Sally. Sally is the research assistant who's actually delivering this activity. So Sally's email address is there, and is the main West contact as well. Okay, thank you.